Hello friends, welcome to this channel. I am instructor Allison. If you're new to this channel, what we do here is basically teaching mathematics, physics, chemistry, and programming. So if you've not subscribed to our channel, just hit the subscribe button and also like our videos. So in this particular video, we're going to talk about electricity and magnetism. Under electricity and magnetism, we'll treat one question on electricity and one question under magnetism. And the one we're going to treat under magnetism is on transformer. And then the one we're going to treat under electricity talks about current, the relationship between current, charge, and time. So just stay tuned and then watch this video. Watch this video right now. Okay, welcome to Instructor Allison Online Tutorials. In this video, we are going to solve two problems. One is under electricity and the other is going to come from magnetism. So the first one is going to come from magnetism and then the second one is under electricity. But they are together. All right. So the first one flows under transformer, but in this video, I will not say much about the concept of transformer, even though we know transformer to be something that transforms. Ideally, in electricity, it transforms. is ideally the work of a transformer does the work of transformation. All right. What it transforms is what we need to discuss in a video where I will be teaching transformer. But in this video, I will be concerned about the formula of an ideal transformer that has to do with the relationship between the voltage and the number of turns. Then in this second problem, I'm going to go straight to talking about the charge, the relationship between the charge, the current, and also the time. All right, let's go straight to the solution to this problem. Find the turn ratio in a transformer which delivers a voltage of 120 volts in secondary coil from primary voltage of 60 volts. All right. The solution to this problem is this. In ideal transformer, the number of turns is equal to the number of turns in the secondary divided by the number of turns in the primary. And this is equal to the secondary voltage divided by the primary voltage. In some cases, you will see where the formula reverses, where you will be seeing a lot of cases. But I will show you by the time we talk about the ideal transformer when this secondary voltage is greater than the number of turns in the secondary and cases like that. We're going to explain them in details so that you don't have the issues of knowing which one to use. All right. So the parameters have been given. If you read through this question, you are asked to find the ratio. And when we say the ratio, we are talking about this over this. The ratio, find the turn ratio in the transformer. This is the turn ratio. N subscript S means the number of turns in the secondary, number of turns in the secondary windings or secondary coils, whichever one you want to use. N subscript P is the number of turns in the primary winding. The same thing goes to the voltage. V subscript S is the voltage in the secondary winding. V subscript P is the voltage in the primary winding. So that is the parameter we've used already. So let's substitute the values already inside of it. From the question, we said that they said that voltage of 120 volts in secondary. That means the V subscript S is equal to 120 volts. Again, we have the V subscript P from primary. that is 60 volts. So it is very simple to substitute it into this expression. So at this point we have N equal to the number of turns, or the ratio of the number of turns in the secondary to that of the primary, equal to the voltage in the secondary all over the primary, and this will be equal to V subscript S is 120 divided by V subscript P is 60 volts. If this cancels out, 6 into itself is 1, 6 into 12 is 2. Therefore, N will equal to 2 tons. 2 tons. So that is the unit for it. So this is the answer for this. N signifies the ratio of the secondary tons to that of the primary. So that is the solution to the first question. If this solution makes sense to you and you know you've not subscribed to this channel, please just click on the subscribe button, and also make sure you like this video right now if you enjoy this solution. Let's see the second solution. A 10 microcoulomb charge flows through a conductor in 5 nanoseconds. Determine the current flowing in the circuit. The question is somehow technical because of the involvement of the units. The larger unit involves in it, or the smaller unit, whichever way you can be able to interpret it is okay. So, but then let's fetch out the parameters. We have this one here, 10 microcoulomb, and that is for charge. So we have Q equal to 10 microcoulomb, and this micro means 10 to the power of minus 6. All right, so if we want to break this down, we can have therefore the charge equal to 10 by multiplied by 10 to the power of minus 6 coulomb. So it is very important, you should convert from microcoulomb to coulomb. Again, if you read through the equation, this charge flows through a conductor in 5 seconds. So the time here is 5 nanoseconds. And this nano is 10 to the power of minus 9. So that means we need to convert the time to nanoseconds. All right? So this is seconds. Again, we have to determine the current flowing. So I, which is the current, is not given. So that will also introduce to us that there is a relationship between charge, time, and also current. That means if we have the Q, which is the integral of the T initial to the T final of this I, which is a net outward current, multiplied by the change in time. All right, which this first one is the initial time, this is the final time. This I here signifies the net outward current, and then this dt is the change in time. Oh, I'm dealing with A-level students, so I will avoid using this. Let me not use this. Let me go with the simple expression that will best fit this. There's a relationship between this current, time, and charge, which is Q equal to IT. I think most of you are familiar with this. So let's work with this, all right? Okay, in this case, the time is not given. So we make the time, and that is what we are looking for. Sorry, the current is not given, and that is what we are looking for, the current flowing in the circuit. We make the current the subject of the relation by dividing both sides by the time, and then we have this expression. So at this point, we're just going to do straight substitution. So I now will equal to the Q here is 10 to the 10 multiplied by 10 to the power of minus 6 divided by the time here is 5 multiplied by 10 to the power of minus 9. Therefore, the time will be equal to, At this point, some persons or some students usually have issues when punching this on the calculator. If you have your calculator with you, this is what I want you to do. Instead of you punching 10 multiplied by 10 to the power of 6 divided by 5 times 10 to the power of minus 9, and if you press equal to, the result you may be having is 2 multiplied by 2 times 10 to the power of minus 15. I guess so. That's what you might be having on the screen of the calculator, which might not be correct. So here, if you work on the indices here, you will notice that 10 to the power of minus 6 divided by 10 to the power of minus 9. If you work on indices, this is what it is. And if you don't understand much about indices, I will drop the link to this division law of indices. I've done that already. I'll drop the link to it so that you learn more about the division law of indices in the description of this video. So this becomes, because the bases are the same, I will take one of the common base and I will subtract the power. Why am I subtracting? Because I'm having division sign here. So we have minus, and we have minus 9 here already. So we put it in bracket minus 9. So at this point, minus will change to become plus. All right. So minus 6 plus 9 will then give us 10 to the power of 3. That's what you have. But when you punch it directly on the calculator, you have 10 to the power of minus 15, which is wrong. But if you want to punch it accurately on the calculator, what you need to do is this. Punch 10 times 10 to the power of minus 6, divide by, when you press the division sign, open a bracket. And when you open a bracket, you type in this value, 5 times 10 to the power of minus 9, and you close the bracket. If you press equal to, you have 2 times 10 raised to the power of 3. And the SI unit of current is the ampere, which is A, capital letter A. Since from the question, we have the units in, we have 10 microfarad, microcoulomb, we still have a 5 nanocoulomb. So the answer here, we would like to also place it in its sub or larger unit, which is a 10 to the power of 3 stands for, 10 to the power of 3 stands for kilo. So we can keep the answer as 2 kiloamp, because K is for kilo and it stands for 10 to the power of 3. And this becomes the answer to this particular question. Notice that we applied the right formula by the time we fetch out the parameter. So fetching out parameter is very important. It helps you to know which formula to use and you substitute everything in it. All right? So that is simple. So for all of these and more, I will see you on the next video. Thank you very much and stay tuned. Oh, I've forgotten to tell you that you need to like this video and subscribe to this video. That is very important. If you enjoyed this lecture, click on the like button, click on the subscribe button, and also turn on the notification to all, then share it. You don't want to share it, okay, just do these other ones and leave the sharing. And if you like it, share it. That's no problem about it. Thank you very much. Peace.